So percent yield basically is this formula that we have here at the bottom. The percent yield is equal to the actual yield over the theoretical yield. So you may want to make a note of the formula that is on the screen right now. Actual over theoretical times 100 equals percent yield. You may also want to write that theoretical is from stoichiometry, and actual is either going to be from the problem or you're going to actually be holding it. I think this is an excellent one to add to your journal. We've got two numbers here. We've got the percent yield of 4.10 grams of sodium acetate reacting with excess iron 3 bromide if only 2.81 grams of the solid product is collected. So we've got two values here. We've got 2.8 of the solid product, okay, and we have the 4.10 of sodium acetate. So these are our like starting values. One of these is going to be the actual yield, and the other one is going to be what we actually start with. Now, the thing you will want to look for is you want to look for the words is collected or actual or something like that. So the fact that there's this thing that says is collected right here, that means that this in blue is the actual yield. And since this is the actual yield, this is not what we are going to start with. We're going to keep this until the end. So you just kind of want to like take this out of the equation because you are going to do our like last step with this. Now, since we're going from one thing, sodium acetate, to another thing, this solid product, we have a stoichiometry question that we are dealing with. And if we have stoichiometry, we need an equation. So it says sodium acetate, that is NaC2H3O2. That acetate comes from the back of your table. Acetate's a 1 minus, sodium's a 1 plus, so it's just a 1-to-1 ratio. 1 sodium to 1 acetate. This will be combined with iron 3 bromide, which is FeBr3. Iron 3 being a 3 plus charge, bromine being a 1 minus charge, which means I need 3 bromines to cancel out my iron. This is going to yield two different products. Now, this is a double replacement reaction because we've got two different compounds. So we're going to take the outer elements and combine them first. So that's my NaBr. And when I do this, I want to take a peek on my periodic table. If you look at your periodic table, this one, which you should have printed out or given to you, on the back, you have got this grid. And this grid is what we check for double replacement reactions. So I'm going to check my grid, and I'm going to see what the phase of NaBr is, and it says that it is aqueous. So since it is aqueous, we write that down. We're going to sit there and write that NaBr is aqueous. It also means it is not the solid product. It is the aqueous product. And I'm then going to do the second piece. Now, this second piece that I've got here is my acetate being combined with my iron. Now, the iron goes first because it is positively charged. And then I put my acetate, my C2H3O2. But acetate only has a charge of -1, as I saw earlier, so that means I'm going to need 3 of these suckers. So, 3. Now that I've got this, I got to check, what is the phase of this? Well, iron 3 acetate is actually a solid. So this here is my solid product collected. It's going to be my iron acetate. So I've got that all set up. Now I need to balance this because, whenever we do this, we should balance the equation. And to balance this, all I need to do is I need to put a 3 here so that the acetates are 3 on both sides, and a 3 here so that the sodiums and bromines are 3 on both sides. So that's all I need to do to balance it. Everything else works out. Now, I'm going to start the problem with what it told me in the problem, and that is not the actual yield. So that is the 4.10 grams of sodium acetate. Now I'm just going to call sodium acetate SA, so that way I can just make it quicker. I'm going to take that and I'm going to bring my grams of sodium acetate down. I'm going to change that to moles of sodium acetate. For every 1 mole of sodium acetate, there is, let's see, I got to punch this in my calculator real quick. 82.01 grams. That is the weight of sodium plus the weight of 2 carbons plus the weight of 3 hydrogens and the weight of 2 oxygens. I get 82.04. 82.04. Then I'm going to sit there and I'm going to bring my moles of sodium acetate down. I'm going to change that to moles of iron acetate. I look at the equation and you'll see that there are 3 sodium acetates to 1 iron acetate. So 3 sodium acetates to 1 iron. Now that I'm in iron acetate mode, it says I need grams of solid product in my actual, which means I want my theoretical to match. I want grams of solid product. So I'm going to take my theoretical to match my actual. So I'm going to bring my moles of iron 3 acetate down and change that to grams of iron 3 acetate. Remember, the mole is 1 unless mole to mole. Then we use the equation. So we use the 1. Now let's see. For iron acetate, I punch that in real quick. And I do the weight of iron plus 6 carbons. See, 3 times 2 is 6. 9 hydrogens and 6 oxygens. I get 233 grams of iron 3 acetate. So this is my math. This part's going to give me my theory. So I'm going to punch all of that in, and I am going to get 3.814, etc. So I get 3.8814, and there's more, but I'm not going to care about it because my sig digs are going to round that off. So this is grams of iron acetate, and this here is my theory. This is what I got from my math. So I need to keep that theory in mind because I'm going to need it to solve the question. Now, if we remember, this we've done before. We did chapter 3 over here to make the equation, chapter 4 stoich over here. And so the new part that we're doing for this is just an extra step at the end where we do actual over theory times 100% equals our percent yield. So my actual was from the problem that was highlighted in blue of 2.81 grams of my iron 3 acetate, which was my solid product. That is then going to be over, and while I'm at it, I'm going to just do the times 100% equals, since I'm in that color. And then it's over my theory, which I calculated as 3.8814 grams of iron acetate. Now, if I look at the problem tells me that I have 3 significant digits. So I'm going to take my raw number here. I'm going to round it to 3 sig digs for my final answer. And so my final answer in this case is 72.4%. Double checking my answer. Yep, that's what I got. I'll put a box around it to signify that that is it. And there we go. Now, a quick note, you can indeed have a percent yield over 100%. That just means that there was a contaminant or a goof. It's something that happens. It's not good. It's worse than being under 100%, but it does happen. So you need to be mindful. Percent yield over 100, yeah, it's a problem, but it still is probably your answer. So just write it down and move on with your life. So there's that. Now, to make it a little cleaner, I of course have, everything all color coded and worked out that I've done earlier. And you can see this, you can see the setup and whatnot.